All right, whatever. Let's see what happens. Okay, probably not even recording with sound. Who cares? All right, we need to get going, dividing, and then we're going to get into the rest of this chapter. We're still in 6. So we started chapter 6, and I kind of paused halfway between. You had your last test. Don't lose that test. You're going to need it for the test over the rest of this. Really, where we need to go from here is to get ready to graph polynomials. And to graph polynomials, there's some preliminaries. And so this will finish out the rest of the chapter with polynomials and such. So don't lose your test. You're going to need it for the next situation. And I got to get rid of my pop-ups because you guys are just going to read all my emails. That is great. All right, whatever. Here we go. So dividing with a monomial divisor. So we've got to do a couple monomial. Boy, that is wonderful. Everything's odd because everything's updated. And so the pen looks different. Everything. Desktop looks different. It's not quite responsive. All right, what we got to do is when we divide, what you have to discern between is what is the divisor? The bottom, if you're looking at a traditional fraction. You know, we barely see the old elementary school division symbol. So the denominator. What's the denominator? If it's a monomial, you got to divide one way. If it's a polynomial, you have to divide another way. And so your first thought is, hey, what's my divisor? Is it a monomial or a polynomial? Which would be binomial, trinomial, etc. If it's a monomial, you're going to do it this way. If it's a binomial or greater, you're going to do it the second way we'll look at today. So that's the first thing you got to do. Hey, what is this? Am I dividing by a monomial? If so, we've already done this before. You're supposed to split up the numerator and divide each term of the numerator by the denominator. So you end up with a over d plus b over d, and in this example, minus c over d. So we've really done this before. We've applied this to the quadratic equation and other things. And always when you're doing this, look to reduce when possible. All right, reduce when possible. All right, couple examples and then we'll roll on. You know, if you want to, normally I just do something like this. I'll just stick that divisor underneath each term, right? Because the first thing's a binomial. Right? We got a binomial over a monomial. And just split it up and then just reduce each part. So go ahead and finish that out. Reduce the left-hand fraction. You got a minus sign in between, right? And then reduce that right-hand fraction. Shouldn't be too tough. What do you got? 4n minus 3, right, is what's left. You're just doing a 12n squared divided by a 3n and a minus 9 divided by 3n. Pretty easy. No sweat. Okay. All right, so second one, go ahead and do the same thing. You need to, and be careful, you got a minus 4xyz in the denominator. So underneath each term, you need to put that negative 4xyz. And again, you could take a whole extra step. But we're just going to do that. Go ahead and finish that one out. Okay, so how many terms do you have? 1, 2, or 3? On 3, give me your answer. 1, 2, 3. Okay, I heard 2. Did I hear anything else? 3. So some have 2, some have 3. Who have 2? Who has 2? No one willing to admit it now? All right, there was more than you that said 2, right? Should be 3. And so don't make that common mistake, and that is in the back. So what do we got here? Negative 5, what? X squared, y. Negative 5x squared y. What's your what? The second term is a negative 7, what, x? And then the last term is a positive 1. So negative 5x squared y minus 7x plus 1. All right, so obviously those of you that said 2 and weren't willing to admit it afterwards, you forgot the 1. Don't forget the 1s. Anything divided by itself is 1. Not a big deal. We've done that already. You're just going to split it up. Okay. Any questions on that? Yes, my waste of time question. All right, so second situation. Dividing with a polynomial divisor. And we did do these back in Algebra 1, so if you remember, you have to do these by long division. So to do this, you got to go long division. Let me see if I can still use my shade. Great, changes color every time. Woohoo! Not in pink. Oh, great. Temperamental. All right, good enough. All right, so dividing with a polynomial divisor. So long division, you guys know how to set it up. Back to elementary type situation. Take your divisor. You need the old division type symbol. We've got an x squared minus an 8x minus 20. Okay, so just to try to get you guys to remember what's going on, let me just do a regular old elementary division problem over here on the right. I don't know, let's pick like 110, why not? All right, so if you were going to do the left-hand regular old division problem, you would figure out how many times does 4 go into 11, right? Would be your first thought. And you would say 4 goes into 11 twice, and you would stick a 2 there, right? So on these, it's always the lead term of your divisor. In this case, it's an x. Could be an x squared. This could be a trinomial out there. Could be a 3x, could be a 7x, etc. You're going to take your lead term, and you're going to divide your front term by it. So I'm going to do this off to the side, because this is, you have to understand this to be able to figure out what to put up top. So you can take the x squared, you can divide it by x. We can all do that, and we all know the solution is an x. All right, what I tried to teach you guys is to put the x in the x column. In other words, this is an x to the first power. Put it in the x to the first power column. I don't know if this edition of the book does that or not. Last edition didn't. It didn't line up the factors, and it just makes it easier. It'll allow you to keep track of things. It'll allow you to know when you're down to your denominator or to your remainder. Okay, so we know that's an x. So go back to the example. You would go 4 times 2. I keep getting that bottom thing. You would go 4 times 2 is 8, and you would put an 8 under there, right? And then you would subtract it and end up with a 3. So we have to do a similar situation. I'm going to use red here. You got to take your x and multiply it times your x, and you're going to get an x squared. But you also have to take your 2 and multiply it times your x and get a positive 2x. And again, like long division, you have to subtract this from the original. And don't forget, you got to distribute this negative. Your first term should always divide out. That's all of what you're after. And so be careful here. There's a negative 10x, right? Okay, so the example on the left, old school, you'd bring down the 0. So here we're going to bring down the negative 20. And again, you would figure out how many times does 4 go into 20, or 30, I'm sorry, and you would say 7. All right, where do we go? Come back. What a pain. So you would figure 4 goes into 30 7 times. It is being temperamental. 4 goes into 30 7 times, and you do 28, and you would subtract, and you get a 2 remainder. And if you were in elementary school, right, you would do this, R2. But we're not in elementary school. And I don't know, your book may use remainders, but hopefully you're going to say this is 2/4 or plus 1/2. We're not going to do decimals. Because think about what we're dealing with here, right? We're dealing with variables, we're dealing with binomials and trinomials and polynomials and such. And so we're not going to do decimals, we're not going to go 0.5. That would be plus 1/2. So in our situation, if we end up with a remainder, we're not going to use an R. I don't know if this example ends up that way, but others do. All right, so let's finish our situation. Here's where we're at right now, right? We got a negative 10x minus 20. So again, it's the front lead term divided by the lead term. So how do you figure out what goes up top? Divide a negative 10x by an x, and you get negative 10, right? So negative 10 is there. Again, you got to distribute x times negative 10, negative 10x. 2 times negative 10 is a negative 20. Don't forget, we are subtracting, and the result is 0. So this one didn't have a remainder. And so the final answer would be x minus 10. And look, if we're going to understand later on down the road what we're dealing with, don't forget this fact, right? If you take this x plus 2 and you multiply it times this x minus 10, you're going to get back to x squared minus 8x minus 20, right? Whatever the divisor was times the quotient, the solution to a division problem, will give you the dividend. All right. You guys are so sluggish. Man, oh man. This is like pulling teeth. I hate going to the dentist. Okay, so I'm going to let you guys do this second one. And I'm going to pause and we'll see how you do. So take it from beginning to end. Okay, I think a lot of you are at least close to done. So again, you're going to take your 6n squared divided by your 3n, right? Pretty simplistic. That's a 2n. Put it in your n column. Distribute 6n squared. Again, those should always match. Minus 4n. Subtract. What do you get? 15n. Bring down your negative 10. Divide the front by the front, so now it's a 15n divided by 3n, and that's a positive 5, so you do want that plus sign there. 3n times 5 is 15n, negative 2 times 5, negative 10, and when you subtract, you get 0. Okay. So 2n plus 5. Again, don't lose fact of a 3n minus 2 times a 2n plus 5 does give you the 6n squared plus 11n minus 10. Okay, so just one step at a time. Any questions on that? Anybody? Joanna. So again, if you go back to just old school division, if I had 7 going into 15, I would say 7 goes into 15 twice. I would then say 2 times 7 is 14, but I always subtract it, right? And you got to do the same thing here. What you end up with always has to be subtracted. And you got to have that parentheses because it's got to distribute. You got to subtract the whole thing, the whole binomial. Okay. Any other questions? Anybody else on that one? Anybody else? Okay, let's go to the next one. Okay, so now we've got a a 4-term polynomial, not a big deal. Same concept. For time's sake, let's just belt through this. X cubed divided by x. So now you're going to say x squared, right? And put it in the x squared column. So x times x squared is x cubed. Again, if you did everything right, that front term will always match. A 1 times an x squared is just a 1x squared. And remember, we got to subtract. Distribute that negative. 3x squared minus x squared is a 2x squared. Right. So again, x times x squared is x cubed. 1 times x squared is a positive x squared. Subtract that. You end up with a 2x squared. Bring down your negative 5x. Again, how do you figure out what goes up front? Always take the lead term, 2x squared, divided by the lead term, x. So 2x squared divided by x is a positive 2x. You got to use your plus signs there. So again, distributing x times 2x, 2x squared. 1 times 2x is a 2x. So you get 2x squared plus 2x. Again, you're subtracting. Distribute that negative. Be careful. Negative 5x and a negative 2x is a negative 7x. Bring down your negative 9. Front term, negative 7x. Divided by the front term, positive x, is a negative 7. So again, distribute x times negative 7, negative 7x. 1 times negative 7 is a negative 7. Subtract. And for the first time, you end up with a remainder, right? A negative 2. So look, even if the book, and I can't remember, it was a while ago when I looked at this current book. If they do r negative 2, we are not doing r negative 2. All right? We're not doing remainder negative 2. Again, what you got to do is use the sign. In this case, it's a negative, so the negative should come next. Then the numerator is the 2, and the denominator is the x plus 1. So x squared plus 2x minus 7 minus 2 divided by x plus 1. So whether the book does r or not, we're not going to do r. If that would have been a plus 2, then there would have been a plus sign here, 2 over x plus 1. In whatever situation it is. Any questions? Any questions? Let's go to the next one. Okay, so what if you get a question like this? Is 2x minus 1 a factor of 2x cubed minus 3x squared minus 23x plus 12? The only way you're going to be able to determine if this is a factor is if you divide it. And not only do you have to divide it, you have to get a zero remainder. So this, what the question is really asking is, when you divide it, do you get a zero remainder? In other words, no remainder. And I'll stick implies, yes, it is a factor. So let me put an if here. If no remainder, then it implies yes, it is a factor. So really, what's the situation? The situation is long division. And so we've got to do long division. All right, not a big deal, 2x minus 1. So go ahead and set it up. Again, you're going to take 2x minus 1, 2x cubed minus 3x squared minus 23x plus 12. A couple lessons down the road, we will figure out a more efficient way to figure out if 2x minus 1 is a factor. So that's coming down the road. We're just not ready for it yet. So right now, our method is to go ahead and do long division. A couple lessons down the road, we'll find a little bit more efficient method. So long division. So you go ahead and do it. I'm going to do it as well. If you want to watch me and follow me, fine. But really, you should get to the point where you can start doing it yourself. So I'm not going to talk through it. I'm just going to do it. And you should do it as well. I'll try to go slow. All right, hopefully you got yes. And again, don't lose sight of the fact that if you take the 2x minus 1 and you multiply it times the x squared minus x minus 12, then you would get the original. And if we wanted to further factor this, we could actually factor the dividend, right? So don't do this, but if I took this trinomial and I factored it, and maybe it factors and maybe it doesn't, maybe I've got to use the quadratic equation. Again, don't do this in your notes. So what do we got here? Negative 4 and positive 3, right? Is what that factors into. So really, technically, 2x minus 1 times x plus 3 times x minus 4 equals the original. And really, where we're heading down the road is, if you were asked to graph this, you have to know these factors. Because we talked about zeros before. And what is a zero? A zero is a place where the graph crosses the x-axis. So again, I don't want to go too far on this, but just to begin to try to put things together for down the road. A 2x minus 1, that 0 is a half. So let's say this is 1, 2. You would have a 0 at a half. This x plus 3, you would have a 0 at negative 3, right there. And this x minus 4, you would have a 0 at 4. So I know that the graph of this has a 0 at negative 3, at a half, and at 4. And I know this thing does something like this. And this is where we're heading in the chapter. And when we get there, you'll understand that it does something like that as well. We'll do a little bit more to get it more precise, but that's the beginnings of what we're doing. So long division is really a step in the process. I'm just going to leave that. A step in the process of being able to graph polynomial functions. You know, we don't have quadratics anymore, right? We're past the parabola. Now we've got a curve, and we've got to figure out how to graph it. So long division is one part of the steps of doing that. All right, let's look at our last example, and then really I got to mention one other thing to you. Okay, so now we have a trinomial divided into a polynomial. It's the same thing, right? It's the exact same thing. Nothing changes. Math is orderly. except my smartboard is, my podium is being temperamental. So again, you're going to take the front and divide it by the front. 2x cubed divided by a 2x is an x. Again, I stick it in the x column. It just helps to keep track of things. Still going to distribute, right? What's a 2x squared times an x? 2x cubed. Right? I'm going right down the road here of this trinomial. Right? Oh, this thing is being such a pain. So you got 2x squared times x is 2x cubed. Then we got to do a positive x. Positive x times the x is a positive x squared. Then a negative 3 times the x is a negative 3x. So again, I'm just distributing, and again, I got to subtract. Front term should always divide out. If not, you made a mistake in what you put up top. This is what, a negative 8x squared, and this is a negative 4x. Be careful when you distribute. Right? You got to distribute that negative to all the terms. So negative 8x squared minus 4x. Bring down the 12. Take the front. Divided by the front. Negative 8x squared divided by a 2x squared is a negative 4. Distribute negative 4 times 2x squared, negative 8x squared. Positive x times negative 4, negative 4x. Negative 3 times negative 4, positive 12. Subtract. Another remainder of 0. And guess what? 2x squared plus x minus 3 times the quantity x minus 4 equals 2x cubed minus 7x minus 7x squared minus 7x plus 12. Josh.
Why do you have a 2x in the lower parentheses?
Right here?
Yeah.
I have no idea, because that's a negative 8x squared. No Kool-Aid for Josh. He's the only one paying attention. And hopefully the rest of you just wrote 8x, right? Squared. Beautiful. Good. All right. And 0. All right, couple things, and we're done for today. One is there's a process called synthetic division. There's a couple examples of it on page 260. Some people like synthetic division. I don't know if any of you guys remember Caleb Lloyd. You guys remember Caleb? Some of you do. He hated doing this. Matter of fact, when he did this, he would get them wrong. I don't know how. It's pretty easy. But he would get them wrong, but he loved synthetic division. So he always did synthetic division. There's a problem. You say, well, why don't you just teach synthetic division if it's easier? All right, it's easier, but it's one of those shortcuts to where it only works in certain situations. So feel free to learn synthetic division. The only thing is, it's limited in the kind of problem it will solve. It will solve that type and solve it pretty quickly and pretty efficiently, but it'll only solve that type. So feel free to learn it. Again, there's some examples there on page 260. And if you want to learn it, go ahead and learn it. That's fine. Not a problem there at all. But again, I don't teach it because it won't solve everything. You can't divide every polynomial by a binomial or greater by synthetic division. And because you can't do everything with it, I don't bother to teach it. But if you want to learn it, feel free to learn it. It is an interesting technique. Now, I should have given one more example, so I got to show you guys something here. And I'll just stick it in right here. And you might want to just watch. It's probably the better way to go. Matter of fact, I'm just going to go to a clean part of the page here. So every once in a while, you'll get a problem like this. Again, don't write this. let's say we have something like an 8x to the 4th minus 2x minus 6 divided by, I don't know, let's go with 3x plus 1. Okay, so if you were to go to set this problem up, you would take your 3x plus 1, and you would go to divide it into this, right? So far, so good, piece of cake, right? We understand? All right, well, here's the situation. When you go to write this, I would write the 8x to the 4th, but I would leave a spot, and some students like to do a 0. You need a spot for the x cubed. You may use it, you may not. It depends on what this lead term is. I mean, that could have been a square. This could have been like a 3x squared plus 1. So just write it in. You need a column for the cubes. I also need a column for the squares. I have an x to the 1st power term, and I have a number term. And you'll see real quickly why you needed that. I'm not going to do the whole problem. But again, if you take front, oh great, let's make this a 9. Make life easier. You take, by the way, you can have fractions too. Fun. But front divided by front. So what is a 9x to the 4th divided by 3x? Okay, that's a 3x cubed. So again, where would that go? That would go in your x cubed column. And again, when you would multiply out, what would this be? 9x to the 4th plus 3x cubed. Subtract. And now you have a negative 3x cubed. And you're going to bring down your 0x squared. Because again, what's the next step? Front divided by front. This is a minus x squared, right? And so you needed a column for that. And again, you would finish out. So if they give you a situation where it's not set up already, you look at your 3x plus 1, just put in a 0 of the variable for the descending powers. If you don't need them, so one last look here before I'll let you go. If you don't need them, the math will tell you. So you say, what do you mean by that? All right. Let me do one last shot. You might have something like this. X to the 4th minus 6x squared plus 2 divided by x squared minus 1. So you say to yourself, I need these descending powers. So I'm going to go x to the 4th plus 0x cubed minus 6x squared from the original plus 0x, right, because there's no x term, plus 2. Plus 2, right? Because you say I need my descending powers. So again, watch what happens. 4x squared, or x to the 4th divided by x squared is what? X squared. And where would that go? Right there. X squared times x squared, x to the 4th, negative 1 times x squared, negative x squared. Did I need this? And I didn't, but it didn't hurt anything to have it there. So there are some situations where you won't need them. But if you always put them, you'll have them there and they'll be ready to go. All right, I think that's enough. One note here, I'm not sure when your report cards are coming home and when you're getting them. So the greater than B minus, don't worry about 36 tonight. Because some of you don't know if you're greater than B minus, right? So, and if you want to knock yourself out and do it, feel free. But you don't have to. You don't have to. You don't have to.